Hello, algebra. I wanted to just take a few minutes to give you a brief review or introduction to the concept of inequalities, and kind of sound complicated, but really not. We have what we normally think of a function or as an equation. So we would have something like, oops, gotta turn my pen on, 14 equals 2 times the variable x. And this is not overly complicated algebra. You probably can figure out that 2 times 7 is going to be the solution to this. And actually, I'm going to write it kind of the way we'll do it down the road. We talked about mathematical opposites and the idea that 2 is multiplied by x. So if I want to move the 2, I can divide by 2. Anything I do to one side of the equation, I do to the other. And 14 divided by 2 is 7, so 7 equals x. So 2 times 7 equals 14. We know that. If I try to do this same thing and I say, well, gee, what if I make x equal 6? And so if I do 14 equals 2 times 6, 14 equals 12, wah, wah, that is not the case. So 6 does not create an equality, but 7, however, does create an equality, because when I plug that in for x, 14 equals 14, and yes, we know that is true. But in some cases, we may work with a situation that doesn't have only a single correct answer. There may be a range of correct answers. And so I might have a situation where I want to know, when will this be true? And so that is a different symbol. That is not a symbol of equality like the equal sign is. That is the symbol of inequality. And so just to review the various symbols for inequality, we may have x, y. So this means that x is less than y. So on this, you'll note, and I think I can change my color, that the small end of the caret, as this little angled symbol is called, the small end points toward the smaller quantity, while the large end points toward the larger quantity. So in this case, x is smaller than y. And so we say x is less than y. You could also say the opposite of that, and that y is greater than x. So you could even say that backwards. But the large end is always pointing toward the larger quantity. So if I flip that around, I can say x is greater than y. It's greater than y. I can also have a situation where x may be less than or equal to y. So less than or equal to y. Notice we kind of have both the equal sign in there, and we have the less than. So this is, oh, turn my pen off. X is less than or equal to y. And then finally, I can do it the other way. X is greater than or equal to y. So those are kind of the various symbols that we use for inequalities, of the caret to be greater than or less than, and then the underline to show that it includes both an equality and an inequality. So if I go back to my question here, I'm going to solve this exactly the same as I would. I kind of ignore that inequality for a second, and I still solve it just the way that I would. So I would say divide both sides by 2. Divide both sides by 2. I would get 7x, and I put my sign back in. So x, or 7 is less than x, or x is greater than 7, which means that for any value of x greater than 7, this inequality should be true, that 14 14 is less than 2x. So let's try it. What's a number that's greater than 7? Or what's the number that 7 is less than? Well, let's say 8. So if I take this equation, 14 is less than 2 times 8. 14 is less than 16. Is that true? 14 is less than 16? Yep, so my inequality is true. It is accurate. What if I put in, let's say, 6? So, gee, that's not less than 7. Let's make sure that this doesn't work. So 14 equals 2 times 6. Excuse me, 14 is less than 2 times 6. 14 is less than 12. Womp womp. That does not work. So basically our answer to this, this particular inequality is going to be all numbers greater than 7. So the math is the same. I'm still looking for a number that 2 times that number relates to 14. But just instead of saying I have one single answer that equals 14, I have an entire set of answers that will fulfill that inequality. So I have a huge set of answers that that will be actually the solution to this, all numbers greater than 7. So there'll be a few practices with these. We're going to pull in inequalities from time to time. It's kind of like every time we do a particular skill with equalities, we'll then add a little layer to it of inequalities. And that will be some pieces down the road. But for now, please make sure you know the various symbols for inequalities in addition to our good old friend, the equal sign.